My name is David Crumley, and I was a computer engineer on the project. I was personally responsible for the motor assistance system we see here on the front of the cart. Now I'd like to hand it off to Min Park to talk about his portion of the project.
Hello, my name is Min Park. I'm also a computer engineering student, and I was responsible for designing and creating our temperature sensor and our cooling device. And now I'll pass it off to Akil and Fawn.
Hello everyone, my name is Phung Thi Young and I'm an electrical engineering on the project.
Hello, my name is Akil Ahmad and I'm a student of electrical engineering, and we both worked on a solar charging circuit for our load.
Okay, so here we can get a closer look at the motor assistance system. Within this box right here, I have a potentiometer. Out of it comes a shaft that connects to the telescopic handle. As I pull on this telescopic handle, the voltage across the potentiometer increases, telling the motor control circuit to put more voltage to the motor. If I get up and pull on it, we can see it in action. So now we just saw the motor assist system at a glance, but here we get a better look at each of the components of this part of the project. Here we can see some of the circuit. With the box open, we can also see how the motors are connected to the wheels through the belt drive.
Here we have display for our solar charging circuit, and let's turn it on. We can see how much voltage solar panel is generating and how much current is going out of solar panel. We also have the battery display and the duty cycle. Right now battery is in bulk state, so it should get as much power as it can from the solar panel, and this duty cycle will increase or decrease based on the requirement. So right now we are getting 24 watt and it should increase up to maximum value, and let's see how much it can give it us. The duty cycle is at its maximum points and we are getting power up to 36 watt, and since the battery is in bulk state, so that's why it's getting the maximum power. But with time, the duty cycle will change. Even the current going the battery will also change depending on the requirement.
But right now one of the sensor in our batteries is broken, so we already order another one and it's gonna be replaced soon with the sensor right now that we're having.
Talk about our sensor in last video, they were not working properly, so we replaced the old sensor with the new one, and as you can see we are able to get 37-38 watt from solar panel and it's charging the battery. And since the battery is in bulk or absorbed state, so it should give us more power. That's why it's running at a maximum power point tracking, but with time it reduced the current and battery state of charge will increase.
All right, now let's take a closer look at our Peltier refrigeration system. As you can see, the fans are moving because our internal temperature of the cooler is lower than our set temperature. So let's change that really fast. All right, so now the internal temperature that we set is 71, while the inside temperature of the cooler is at 75. So you can see the fans moving. So our Peltier refrigeration system consists of 2 heat sinks accompanied by 2 fans. And on the top part, you can see the fan here and a heat sink underneath this cover, which blows the air out through the heat sink to not cause our Peltier device to overheat. While on the bottom side, and on the bottom side, you can see another fan here that disperses cold air throughout our cooler. All right, so our next video is going to be a time lapse of our cooler in action. We set our temperature to 50 degrees, so we're going to watch our cooler drop down to that temperature, as well as our charging circuit working. You'll be able to see the battery charging while the cooler is draining battery as well.
In this clip, we have a demonstration of the testing procedure for the motor assistance system. For the first step of the procedure, we will pull the cart with the motors off and no weight inside of the cooler. I'll stop the video at key moments to get a good look at the force needed to pull the cart. The first key point is when we want to get the cart moving initially, as this moment is usually the most strenuous for the user. Right here we can see we have about 13.1 pounds on the scale. We see the force drop as the cart gets rolling. The next key point will be when the cart goes from concrete to grass. Here we have about 7.9 pounds. As we continue moving, we'll take another point at the middle of the grassy area. Here we see 9.1 pounds on the scale. And this will be the last key point we measure for this testing procedure. Now we will demonstrate the M.A.C system with the motor assistance enabled, pausing at the same key points to demonstrate the effectiveness of the motor assistance. We can see here that the handle itself has a weight of 2.6 pounds. The initial movement of the cart requires significantly less force now. As we can see, it's only showing 3.3 pounds. We can also see that moving from concrete to grass has a negligible change in the amount of force required. Here showing only 2.6 pounds as we change from concrete to grass. And as we can see here, the user should not even notice the difference between grass and smooth concrete while pulling the cart. Here our scale showing only 2.5 pounds. Now this demonstration proves the effectiveness of our motor assistance with no weight in the cooler. However, it is unlikely that someone will bring an empty cooler with them, so we must test with weight. Now that we know the motor assistance is functional, we want to demonstrate how effective it will actually be. For the first weighted test, we added 11 pounds to the inside of the cooler. Again, we are showing the cart with motors off first to get benchmark force measurements. Here we can see that the force needed for the initial movement has increased as expected. Our scale here showing 11.1 pounds. Now the force needed to pull after it has started has also increased. Here we see the force needed to move from concrete to grass, showing around 9.3 pounds on our scale. Here we see the weight needed to move the cart rolling through grass. 10.2 pounds we see here on the scale. Next, we will do the same test, but with motors engaged. Now that the motors are engaged, we will pull the same 11 pounds and see the difference in force on the scale. So the first major difference is the force needed in the initial movement phase. The cart can now be moved with less than half of the original force required. We see 5.7 pounds on the scale now. The rolling weight is also reduced dramatically. And we can see here one of the greatest effects of the motor assistance is that the change in terrain has almost no effect on the user. The scale is showing 4.7 pounds, the same it was showing on the concrete. Rolling through grass also now requires about half the force it did earlier. Our scale here is showing 6.4 pounds. The system seems successful so far, but let's see if more weight will change this.
For the final test of the motor assistance, we added another 10 pounds, making a total of 21
Another
pounds.
10 pounds.
Let's see how it goes with the motors off.
No power. Let's give it a go.
We see here the increased initial movement force. Our scale's reading about 16.8 pounds. Now with the added weight, the momentum actually helps push the cart over the grass without much of a change in required force. Scale's looking about 9.4 pounds right now. But we definitely see an increase in the weight when rolling through the grass. Right now the scale is showing about 12.9, but it does go higher. Next we'll see if the motor assist will still be effective with this added weight. With the motors enabled, let's see how the cooler handles the 21 pounds. Now it is evident that the decrease in force needed to initially move the cart is not completely satisfactory. Our scale here is showing 9.4 pounds. But again, the user will not notice that we are now pulling the cart through the grass. Scale now only showing 5.4. We can see here that the force required to move the 21 pounds is about the same as was needed for the 11 pounds. This shows that the motor assist is indeed effective, if not completely satisfactory. Our scale here is showing only 6 pounds. And this will conclude the testing of the motor assistance of the M.A.C system. We believe that with a higher gearing ratio or higher voltage motors, we would be able to greatly improve the power delivered by our motors. With more time, these improvements would have been made.
Start.
Woohoo! See that?
It works.
All right,
Well, we'll see if it works.
Not even doing anything. Not even barely pulling it at all.